Did we get it? Zinc hydroxide, taken twice, solid, in equilibrium with zinc and hydroxide. Don't need an ice chart here. Next question, 21 says, what's the KSP expression? So, Stephanie, what is the KSP expression for this fellow? What would I write? Just the expression. Good. To the second power. Okay. Then the next question says, calculate the OH minus in equilibrium with 1 times 10 to the minus 4 molar zinc ion if the KSP of zinc hydroxide is 4.0 times 10 to the minus 17. Okay, I have that value, and I have this value. Can I find OH minus? Same problem, right, but different numbers. Okay, so I'm just going to plug in, and I'm going to say 4.0 times 10 to the minus 17 is equal to 1 times 10 to the minus 4 molar times OH minus squared. Just putting parentheses because I feel it. All right, so divide both sides by 1 times 10 to the minus 4. I don't want a calculator. What's 4 divided by 1? 4. All right, what is 10 to the negative 17 minus a negative 4? Negative 13. That equals hydroxide ion squared. Take the square root of both sides. Square root of that. Square root of that. That goes away. What's the square root of 4? 2. And then, how do I do 10 to the negative 13 raised to the 1/2 power? 6.5 negative. Okay, it's okay if I don't have a calculator. Okay? It's okay if I don't have a calculator. All right? And then I can put it in the calculator that way to get the real number out. Okay? If I need to. I know there's no such thing, but we can do that. I'm trying to help you see the mental math piece. All right. So back to the other question, one right before that. Here's the same question, but it's verbalized a little differently. And I can't tell you this is exactly how they're going to verbalize it. So you've got to have that practice to help you with the same kind of problems, but verbalized a little differently. That's why I give you some book questions and OW questions and all kinds of stuff to help you practice. So this one says we got silver chloride. We can do 1 and 2 easily, right? Okay. But the third one here says silver nitrates added to a solution that already has 1 times 10 to the minus 2 molar sodium chloride. And I put in parentheses the sodium and the nitrate are going to spectate. But you've got to be able to handle taking 2 different ionic compounds and putting them together and looking at only the insoluble guy. So you're going to ignore sodium and ignore nitrate from both of these 2 different sources and focus in on the silver and the chloride. That's where your solubility rules are going to come into play. Sodium and nitrate always spectate, right? Or they're always soluble, so in this situation, in this chapter, they're always going to spectate. So I can cross them out. It says, at what concentration of silver does a precipitate of silver chloride just start to form? All right, there's another way of them saying it's at equilibrium. Okay, right here. That means it's reached or it's at its equilibrium spot. That verbiage is what that means. All right, silver chloride, solid, in equilibrium with silver ion and chloride ion. KSP expression is this, silver ion in brackets times chloride ion in brackets. KSP of silver chloride is 1.8 times 10 to the minus 10. I'm looking for the silver concentration, that would go with the concentration of, now, quick little aside. If I have a 1 times 10 to the minus 2 molar sodium chloride solution, and sodium chloride is 100% soluble, yes? What are the molarities of my 2 ions? Same. Same, Brianna. Same. Is that something from Unit 2 that you better pull back out of the brain? You better. You better. 1 times 10 to the minus 2 molar chloride. Do we know this to be true? We better. If you don't, we're in trouble. Soluble things, you look at their mole ratios in their subscripts to determine their individual molarity values. You've got to pull that back out from Unit 2. Completely 100% soluble compounds are going to break up 100% into their ions. And so, since this one's 1-to-1, his molarity will be the individual molarity of each of his individual ions. Therefore, I go over here and I plug in 1.0 times 10 to the minus 2 molar. I don't need a calculator. 1.0 times 10 to the minus 2. What's 1.8 divided by 1? 1.8. What is 10 to the negative 10 minus a negative 2? Negative 8. Voila. I have found my silver ion concentration. See, I'm adding in some silver nitrate, which only the silver matters because the nitrate's going to spectate. And when I get to this exact molarity, with that exact molarity of chloride already present, I'm going to have a saturated solution that's going to be right at the point of starting to make solid. Going from the right side back to the left side. So this was a different angle. This was looking at starting with products instead of reactants. All right, your owl is open. 1 through 5 is as far as you can try to go if you start it today. 13 total. 13 total. Oh, the outlining's due today. I better see it today before you leave or it'll be late. It will be late. Your outlining's due today, so if you want to bring it back, that's good, but I got to see it. Otherwise, leave it. Chapter 16, reading and outlining. I see Kelsey's and Ira. That's all I see.
On what? Oh, okay. I forgot about that.
Miss Eshbut's got computers. I'll go grab one first.
Thank you. Sorry, I don't know. This whole unit, I just didn't understand.
It's a equilibrium. Once you get going on it, it gets a little easier, but it's tough.
Like, I thought I understood it when you were in class, and I could give you examples, but when it came to how, like, I sat there and read this text, like, a couple times, and I was just getting this wrong, and I couldn't figure it out. I just got frustrated. I was like, I'll just do it tomorrow. I couldn't think of it. All right. I wanted to find it.